This video will explain how to work problem number 3 on our chi-square problems, dealing with the female fly who has true or normal wings. Remember, we learned that true meant homozygous, and that flies crossed with males that are dumpy wings, and all of the F1 end up with normal wings. So if all we cross normal, homozygous normal, with homozygous dumpy, and all the offspring are normal, that tells us that our wild type is dominant. And we look down here and we see that the males and females don't inherit it any differently, pretty much the same. So is dumpy an X-linked trait? No, it's probably just a regular old dominant recessive kind of trait. So using the correct nomenclature, we're going to show this cross. So we have we're going to use DP and DP for this kind of thing. So we're going to cross DP plus, cross with DP, DP. These are our wilds. This is our mutant. We did a little Punnett square. DP plus, DP plus, DP, DP, DP plus DP, DP plus DP, blah, 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 blah. So 100% are going to be DP plus DP. They're going to be heterozygous for the normal wings. So we're going to take males and females of this and cross them. So DP plus DP cross with DP plus DP, these heterozygous individuals. If we do this cross, do I really need to do this cross? Okay, I'll do it. DP plus DP, DP plus DP. This one's going to be plus plus. This one's going to be DP DP. This one's going to be plus. This one's going to be plus. So we should get a 3-to-1 ratio of wild wings to 1 dumpy wing. 3-to-1. These are going to have the dominant trait. This one's going to have the recessive trait. So we're looking at 75% and 25% here. So looking at this is our outcome. So what is our total? Well, our total is 243 plus 225 plus 62 plus 81. So we have a total of 611 flies. Out of that, we expect 75% to be wild, and we expect 25% to be dumpy. Okay. So how many wilds do we have? Oh wait, just kidding. So 611 times 0.75 gives you 458. So that's 458, and we're going to just leave that as 458. And then 611, because we had 611 total flies produced, and we expect 25%. So that's 152. We're going to round up, so that's 153 flies, because you can't have 3/4 of a fly. So this is our expected value. All right, so what did we really get? Well, 243 plus 225, we get 468 total wild, and we get 62 plus 81, 143 dumpy. Do a video. So this is our expected values. How many degrees of freedom? Well, there's 1 degree of freedom because there is either wild or dumpy. 2 options. -1 is 1. Calculate our chi-square. So we take observed minus expected squared divided by expected. Observed, we observed 468, and we expected 458, square that, divided by our expected 458, plus, we observed 143, because 62 plus 81 is 143. We expected 153, square that, divided by 153. Plug this numbers in the calculator, 468 minus 4. So that's 10 squared divided by 458, and that is 0.218 plus, again, that difference is 10, so that's 100 divided by 153 plus 0.654, because we round that up to 3 places behind the decimal, so 0.654 plus 0.218 is, this total is, so our chi-square is 0.872. Alright, now we take our little handy dandy table, and we're looking for 0.872 on the 1 degree of freedom row. 1 degree of freedom, 0.872. 0.872 is somewhere here, because here's 0.4 and here is 1, so it's somewhere between 0.25 and 0.5. So what is our p-value? Our p-value is between 0.5 and 0.25. So if you wanted to get fancy, you could make it look like this. So p is bigger than 0.25, but it's less than 0.5. So is that within the realms of possibility? Is that acceptable data? Yep, it's on the happy face side of this line. So yes, do we accept or reject? We accept. So finishing it up, my chi-square was 0.872. My p-value was between 0.5 and 0.25, and that is an acceptable value.